Suppose I had f of x equals 2x minus 3 squared times x minus 5 times x plus 2. The leading term if I were to multiply all this out, 2x minus 3 would be two of my factors. So it'd be a 2x times a 2x, so I just do 2x squared. So it's 2x squared times the x from this one times the x from this one is going to be 4x squared times 2 more x's is going to be 4x to the 4th. So this is my leading term. It's got a positive exponent, or its positive coefficient, this 4, with an even exponent. So like a parabola, it's going to end up going like this and like this, and the extra terms determine what goes on in here. The zeros, if I put 2x minus 3 equal to 0, and if I do it twice, I'm going to get the same answer, so I don't need to do that. So 2x minus 3 equals 0 is going to give me 2x equals 3. When I divide by 2, it's going to be x equals 3 halves, which is 1.5. This one is going to give me x equals positive 5. This one is going to give me x equals negative 2. Now this one has multiplicity 2 because it's squared. So let me give you this rule. If the multiplicity, that just means whatever the exponent is. If the multiplicity is odd, then the graph goes through the x-axis at that x-intercept. But if, as in this case of the 3 halves, if the multiplicity is even, it means the graph is tangent at that x-intercept. Which means instead of going through, it bounces off. So let's see, we've got the points 1.50, it's supposed to be a 1, 50, negative 2, 0. For the y-intercept, you take what you get if you put 0 in for x. So if I put 0 into the first one, it's going to give me negative 3 squared. So just take the constant raised to the exponent times negative 5 times 2 is going to be 9 times negative 10 is negative 90. So I've got another point, 0, negative 90. Aren't those nice and crooked? So I've got 1.5, 0. I'm just going to declare this one to be 1.5. I'm going to call this 5. I'm going to call this negative 2. And then I'm going to decide this is negative 90 down here. So I've got this point, this point, this point, and this point. Now I know the graph is going to go off into outer space at both ends. So this is going to go up this way and up this way. The graph goes through at these points because they have multiplicity 1, and it's going to be tangent at this point. So I know it goes through here, and then it comes down here. That might or might not be the point where it actually turns around. I know it goes through at the 5. And fortunately for me, I know that it bounces off at the 1.5. Because if it went through, then there's no way it could also go through at this point. So this graph is going to look something like this. It's going to come down through here, up this way, bounce, back down, come up this way, and then go back up forever.